Hello friends, welcome back to our channel. In this video, we are going to discuss about the basic computer architecture. As Devops and Cloud Engineers, we work on infrastructure on on-premises as well as on different clouds. For example, in cloud like AWS, GCP, OCI or Azure, we create different virtual machines and also containers and so on. So, while creating these virtual machines or containers, we choose and configure different parameters like CPU, memory, disk storage and so on. So we need to understand how these CPU, memory, disk storage work together in a computer architecture so that this knowledge would be useful while creating and managing the infrastructure in any of the clouds as well as in on-premises. So now let's discuss about different components of computer architecture and we would see how they interact with each other. So let's start. This diagram shows the basic computer architecture. Here we have an important component called CPU. The CPU or central processing unit is responsible for executing the instructions of various applications, operating system and so on. CPU contains different subunits like control unit, arithmetic and logical unit, and also we can have like floating point unit. Together we can call them as functional units. We also have registers for temporary storage of data. So this arithmetic and logical unit and functional processing unit will do the actual operations like arithmetic operations and logical operations and so on. Generally, ALU is responsible to perform the arithmetic and logical operations on integers. For performing calculations on floating point numbers, we use floating point unit. So both of these are part of CPU. So to execute the instruction, CPU will read the instruction from main memory, which is also called as RAM, random access memory. So this RAM contains the instructions and corresponding data required by instructions. So CPU will read the instructions from main memory and those instructions will be executed via ALU or FPU based on the requirement. Before performing the operations by using ALU and FPU, CPU stores the information in registers. We have various type of registers which store the instruction as well as corresponding data temporarily so that the CPU will use them for execution. Registers are fastest type of memory because they are within the CPU and CPU does not need a separate bus to access the contents. For reading the instructions, we have separate group of wires which is called as bus. So we have different types of bus here. For example, data bus will be used to move the data between CPU and main memory. Similarly, address bus will be used to point to a particular address in main memory so that the instructions or the data will be read from that address. And we have IO bus which transfers the data between IO devices and memory and so on. So we have operating system and applications and corresponding data will be loaded to main memory before execution by corresponding CPU. So where this operating system, applications and data will be stored in a computer. For that we have secondary memory which is also called as the disk storage. So whenever we execute a particular application, so that application program will be loaded from disk storage to main memory. Corresponding data also will be loaded to main memory from disk storage. So once the data and instructions are loaded to main memory, then CPU will read those instructions and it will execute. So the purpose of secondary memory or disk storage is to store the operating system, applications as well as data permanently. We also have different input devices like keyboard, mouse, and we have corresponding output devices like monitor, printer and so on. So CPU will interact with these devices by using corresponding IO controllers. We also have cache here. So this cache will store the recently executed instructions and corresponding data. Whenever the CPU tries to execute an instruction, first it will check whether corresponding instruction and data are present in the one of these cache like L1 cache, L2 cache and L3 cache. If it is present in one of these cache, then it will directly execute it. If it is not present, then it will check in main memory. So this way the performance of the applications will be improved. Here we have shown this block as single processor, but we can have like multiple processors, like multiple cores. Each can perform the similar tasks to improve the performance of application executions. In addition to CPU, which contains like multiprocessors or multi-cores, we also have another unit called GPU, which is graphics processing unit. This contains many number of cores. Each core will be used to perform a particular operation. These cores in this GPU will be used for parallel processing. When we have a single instruction which can operate on multiple data by using these many number of cores at a time, we can use GPU. So in that case, CPU will interact with GPU to perform that operation on multiple data using large number of cores. So this GPU can be used in addition to existing CPU for high performance applications like machine learning, artificial intelligence, and so on. Here we also have control unit as part of CPU, which generates all the timing and control signals so that all components will coordinate each other to perform the required execution within this architecture. Now we have discussed about the basic functionality of each of the component. So let us discuss about these components in detail in the next slides. Now let us discuss about CPU and GPU. CPU means Central Processing Unit and GPU means Graphics Processing Unit. Both CPU and GPU executes instructions from memory. This memory can be RAM or cache. So both CPU and GPU execute instructions by fetching them from cache or memory. Then what is the difference between CPU and GPU? CPU is basically a generalized processor. It handles the main processing functions of a computer. So basically it is designed for serial instruction processing. So it fetches one instruction from memory and executes it, and then next instruction, and then next instruction, and so on. This CPU executes the system instructions of operating system. So this CPU will take care of the execution of instructions of OS kernel. It also takes care of branching and interrupts and so on. Branching means, for example, in our programs, the execution of instructions based on different conditions, that will be taken care by branching, and those will be executed by CPU. And also if any interrupts during the execution of instructions, then the CPU will pause the current program and then it proceeds with the interrupt handler. Once the interrupt handler is completed, again it will come back to main process. So basically CPU is used for general purpose computing applications like taking care of instructions of OS kernel and also the branching, interrupts, and for the applications wherever we need the sequential processing of instructions. For example, web applications, databases. So these application instructions will be executed by corresponding cores in the CPU. So CPU generally contains fewer or more powerful cores which will take care of the processing of serial instructions in a computer. So now let us come back to GPU. GPU is Graphics Processing Unit. So this contains like lot of cores, and each core will act as a specialized processor, and these many number of cores are designed for parallel processing of instructions. Let's take an example of image. So this image contains like number of pixels. If you want to process this image, these GPU cores will process all the pixels at a time in parallel. That means the processing of this image will be very faster in a GPU when compared to CPU. So this GPU contains many cores, and these cores are designed for parallel processing of instructions. That means it follows SIMD, single instructions on multiple data. So that means single instructions will be applied to multiple data points which will be processed by many number of cores at the same time. So the applications would be wherever we need the parallel processing of data. For example, high performance computing applications like machine learning, artificial intelligence, and so on. So generally when we create a virtual machine in a cloud like AWS, GCP or Azure, we need to check for which application we need the machine. So accordingly we need to choose machine type. For example, in AWS we need to choose a machine with corresponding how many virtual CPUs, and also whether this type of machine will include GPU in addition to the CPU for execution of instructions. For example, for machine learning applications, we choose a machine which contains the CPU as well as corresponding GPUs. Now let us discuss about ROM and RAM. ROM is also called read-only memory. RAM is called as random access memory. So let's discuss about ROM first. As the name indicates, it is read-only. That means we cannot write data or programs to ROM directly. It is also non-volatile. That means whatever data or programs we store in ROM will not be lost even if we switch off the computer. So what is the main function of ROM? In the computer we have hardware, operating system, and the user applications. When we switch on the computer, initially the entire hardware needs to be initialized. For example, the RAM, the IO devices like keyboard, monitor, etc. needs to be initialized. And once the hardware is initialized, then the operating system needs to be loaded into RAM. So to initialize the hardware and to load this operating system into RAM, we have a program called BIOS. So this BIOS will be stored in ROM. So when the computer is switched on, the program or the instructions which are stored in ROM, for example BIOS, will be executed so that the hardware would be initialized as well as the operating system will be loaded to memory of the computer. So once the OS is loaded, and then OS would take the responsibility of interacting with hardware as well as user application programs. So here the ROM will contain the permanent instructions, for example BIOS, which is responsible for booting of the computer. It stores the permanent programs, which is also called as firmware, and the capacity will be lesser. This ROM is also slower when compared to RAM. So now let us discuss about RAM. RAM is also called as random access memory and also be called as read-write memory. That means we are able to read as well as write data or programs to the memory. Generally, the CPU will read the instructions from RAM and execute them. So for example, we have a program called some example.python, so which contains some instructions, instruction 1, instruction 2, and so on up to instruction n. So when we want to execute this Python program, so we will use Python interpreter. So when we execute Python interpreter, that program will be loaded to RAM. So CPU reads data or instructions one by one and then it will execute the instructions. Once it finishes executing all the instructions, then the program will be moved out of RAM. So this RAM contains only the temporary programs or data. That means once the execution of the program is completed, the program will not be stored in RAM anymore. That means RAM is volatile and it stores the temporary data or temporary programs. For example, if you open the browser, for example Google Chrome, that will be loaded into RAM and that will be present in RAM until we close the browser application. So it has larger capacity and it is faster when compared to ROM. So this is about ROM and RAM. So ROM contains the read-only instructions or permanent programs, and RAM contains the read-write memory or the temporary programs which stay in the RAM until the program is executed or until we switch off the computer. Now let us discuss about the disk storage or SSD storage. Till now we have seen that the operating system, applications and corresponding data are loaded to RAM before the OS or application programs are executed by CPU. But where this operating system and applications and corresponding data are saved before being loaded to RAM. So disk storage is the location all of these will be stored as corresponding files and directories. For example, in Windows, we can see these are stored in terms of drives like C, D and so on. In Linux, we have corresponding mount points. So these are different mount points where the applications or data will be stored as files and directories. So these mount points actually map to corresponding disks in the Linux operating system. This storage is non-volatile. That means whatever stored in the disk will reside even if we switch off the computer. The disk storage is permanent storage in which all operating system, applications and data and so on are stored as files. We have various types of this disk storage. For example, HDD, SSD, NVMe SSD and so on. Here HDD means hard disk drive. This is based on the magnetic platters and corresponding magnetic head. Here we have magnetic spinning platters which rotate with some speed, and then we have magnetic head, and this moves mechanically for the read and write operations. So here the speed of read and write operations are depending on how fast this head moves. So because of this mechanical movement, hard disk drive is considered slow when compared to other type of disk storage. So by using HDD, we will get less number of IOPS, which is nothing but input output operations per second. So the next one is SSD, which is nothing but solid state drive. Here the data will be stored in electronic cells. So here we don't have any moving parts, and here the cells are based on NAND gates. So since it is using the electronic cells, it is very fast when compared to HDD. So by using SSD, we'll get more number of IOPS when compared to HDD. So the next one is NVMe SSD. So this is an improved version. So this uses protocol NVMe. So basically this is used for parallelism. So if you have multiple cores, those cores will access SSD in parallel by using this protocol. So this will improve the speed of the IO operations. So this will provide more IOPS when compared to HDD or SSD. So in cloud like AWS, GCP, Oracle Cloud or Azure, we need to select. So based on IOPS requirement and corresponding cost requirement, we need to choose corresponding SSD, HDD or NVMe SSD and so on. Now let us discuss about the cache in a computer or any machine like virtual machine. Generally CPU will fetch the instructions from memory and it will execute those instructions. This CPU to memory communication will happen via a bus. So this bus is a group of wires. Every time the CPU needs to execute an instruction, it reads corresponding instruction from memory via this bus. So this is a bit slow process which will impact the performance of the computer. So we have a device called cache. This is a storage device which is placed in between the CPU and memory. So the recently accessed instructions or data will be placed in cache. So whenever CPU wants to execute an instruction, first of all it will check in cache. If the instruction or corresponding data is present in cache, then it will read it and it will execute the instruction. In that case, the CPU does not need to communicate with memory for fetching the instruction or data. So this will improve the performance of the computer. So we have different types of cache: L1 cache, L2 cache and L3 cache. So this L1 cache is directly embedded within the CPU chip. So that means this L1 provides the immediate access to the instructions or corresponding data. So that means this is very faster because the CPU does not need to access the devices through the bus. So here we can see multi-core processor. We have 2 cores. For each core, we have corresponding embedded L1 cache. So whenever the CPU wants to execute the instruction, these cores will try to check whether the instruction or corresponding data is present in L1 cache. If it is present, then it will directly read from here and it will execute it. Since this L1 cache generally embedded within the CPU chip, so the instruction execution will be very fast. The next one is L2 cache. The L2 cache can also be embedded within the CPU, or it can reside in a separate chip which is connected via high-speed alternate system bus. That means it will not use the actual bus between the CPU and RAM. It has a separate high-speed alternate system bus. So that means the data transfer from this L2 cache to the CPU will be very fast when compared to the data transfer from RAM to the CPU. So it will bypass the main system bus and it will reduce the traffic delay. So when the core or CPU checks the instruction in L1 cache, if it is not present, then it will check in L2 cache. If it is present in L2 cache, the core will execute the instruction which is present in the L2 cache. Otherwise, it will check in L3 cache. So this L3 cache, so this is a shared cache among multiple cores within the CPU. So this L3 cache is not very fast when compared to L1 cache and L2 cache, but it is faster when compared to the RAM or DRAM. This way, L1 cache, L2 cache and L3 cache store the recently executed instructions and corresponding data so that the CPU or the cores can fetch those instructions and data directly from the cache instead of RAM. So these different types of cache enable the better performance of application execution within the computer. Now let us discuss about registers in the computer architecture. Registers are the smallest and the fastest memory type in the computer architecture. They reside in the CPU itself. If this is the CPU, we also have registers inside the CPU. Let's say program counter, instruction register, memory address register and memory data register. Generally, CPU fetches the instructions from memory. So these registers will be used as temporary storage of data while executing the instructions by CPU. For example, program counter will contain the address of next instruction to be executed. So during the execution of instruction, first the instruction needs to be fetched from memory to one of the registers like instruction register. Then the instruction in the instruction register will be decoded by the CPU, and then based on the instruction type, if it needs data, then corresponding data will be loaded into memory data register, or during the processing of the instruction, if CPU needs to write data to memory, then the data which is present in the corresponding memory data register will be loaded back to memory. So, since these registers are in the CPU itself, the arithmetic logical unit can directly access these registers, which will be very fast when compared to accessing the instructions directly from memory or cache. So, these are the smallest and fastest memory type in the computer architecture. Now, let us discuss the difference between the memory and the disk storage. For example, this is the machine or a particular VM where we are running different processes. So the memory as well as the storage will be used to store data. The data can be the instructions in a program or corresponding data which will be used by the programs which we execute. So here the CPU or central processing unit in the machine will execute instructions which are stored in memory. So the instructions are corresponding to program. So these instructions before execution by CPU, those will be loaded to memory. So this memory will hold the instructions which will be executed by the CPU. And also, if the CPU needs data while executing the instructions, it will fetch those instructions from memory and it will execute the instructions. If it needs to store some data into memory, then it will store the data. That means the memory or RAM here holds the instructions which will be executed by CPU and also the data needed by the program. Then how long this data will be present in RAM? The data will be present in RAM until we close the process or program, or until we switch off the machine. If the program or process which is loaded into memory is closed, then automatically corresponding instructions will be removed from the memory. And also if we switch off the VM or the machine, then automatically the data which is stored in the memory or RAM will be lost. So this will not store the data permanently. So this is a temporary storage. So memory will hold the data temporarily, which is required by the CPU for the execution of corresponding programs. And also this memory is faster when compared to disk storage. Before the program or the instructions loaded into memory, those will be stored in the disk storage. For example, if we create a file a.python, so this Python file will be stored in the disk. So until we execute this Python program using some Python interpreter, this will be stored in the disk itself. So once we execute this, these Python instructions will be loaded from disk to memory. So the CPU will read those instructions from memory and it will execute. So once the execution of this program is completed, it will be removed from memory. But the file containing corresponding Python code will be present in disk storage as long as we keep the file in the disk. That means even if we switch off this machine, the code will be present in the disk permanently. That means the disk storage will store the contents or data permanently until we delete them. So there are two main differences. The RAM or memory is faster and disk is slower. Second, the memory or RAM will hold data temporarily and disk will hold the data permanent. So let's take some examples now. If you see the memory here, which is the RAM in our machine, as of now it is using 5.9 GB. For example, if I open a new program, let's say Google Chrome. If you open that browser application, that application will be loaded into memory. So let me open that. Now I have opened a Chrome browser. If you see the memory, it is increased to 6.4. That means the Chrome application is loaded into memory. Corresponding program will be executed by CPU, which is loaded into memory. Now let me close the Chrome application. Now we can see the memory is decreased to 5.8 GB. That means it is removed from memory. That means the program or its data will be present in memory until the program is in execution or until this machine is turned on. Similarly, let's open Linux environment. So this is a Linux machine. Now let's see the memory usage in this machine by using top command. So here we can see there are different processes which are running in this machine. So each process occupies some memory. So as of now we don't have any Java process here. That means if I start a Java process, it will be loaded into the memory. So let me start a Tomcat application. So we have started the Tomcat application. That means a new Java process will be started. So let us see that by using top command. So here we can see a new Java process which is loaded into the RAM or memory in this machine. At this moment, it is using around 8.9% of memory. So this process will be present in the memory until the Tomcat application is up and running. So if we stop the application, that will be removed from memory. But in case of disk storage, the files will be present in the disk until we remove the files. So here we can see different mount points which stores corresponding data of the disk partitions. So if we go to root mount point, so let's go to root. So here if we create a file, let's say test, this hello.txt will be present until we remove this file explicitly. That means this file is stored in the disk storage. For example, if I open vi hello.txt, then we are executing a program called vi. That means this program will be loaded into memory, which requires this file hello.txt. So in that case, the contents of this hello.txt will be loaded into memory as well. So let us open this. So now I have opened a new window. If I execute top here, so here we can see this vi program is loaded into memory. So in that case, the contents of hello.txt are placed into memory until we close the vi program. So this way, the program which is in execution as well as the data which is required by the program will be loaded into memory and they will be there until the execution of the program completes. But corresponding files will be stored in the disk as long as we do not delete those files explicitly. So this is the difference between memory and disk storage. So in this video, we have discussed about the basic computer architecture. As part of this, we have discussed about the functions of each of these components like CPU, memory, storage, cache, and I/O devices. And also we have discussed about some of the important components in detail. I hope this content is useful. If you like the content, please like, share and subscribe. Thanks a lot for watching.